Good day, students. Welcome to part one of the mixed review series on limits. So let's go ahead and take a look at question number one. So question number one, we have to find the limit as x approaches 4 of 2 times the square root of x plus the square root of x. Okay? All right, so to evaluate this limit, we can just plug in the value that x is approaching, so we can evaluate this by substitution. So this is going to become 2 times the square root of 4 plus the square root of 4. Okay, let's go ahead and reduce this. This becomes 2 times the square root of 4 plus the square root of 4 is 2. So the final answer is going to be 2 root 6. Okay, so there you have it. All right, number two, let's find the limit as x approaches -2 of 4 over x plus 2 times x divided by x plus 2 times x. Okay? All right, let's go ahead and figure out what the value of this limit is. So first thing we can do, we can cancel out, but how about, we have an x down here. So if we distributed this x to this quantity in the numerator, it will get rid of this x in this denominator right here. So rather than dividing downwards, which would be a natural inclination, we'll just distribute this x to these two quantities in the parentheses. So that yields the limit as x approaches -2 of 4, because 4 over x times x is 4, plus 2x divided by x plus 2 times x. All right. Now we can factor out a 2 in the numerator and write it in standard form. So limited as x approaches -2, factor the 2 of 2 times x plus 2 divided by x plus 2 times x. Okay, so what happens is that these x plus 2's divide out. So what we're going to have is the limit as x approaches -2 of 2 over x. Now I've simplified it as much as we can. So what we're going to do now is basically substitute. So this becomes 2 over -2. Your final answer is -1. All right, so there you have it. Okay, let's take a look at question 3. So, for question 3, we want to find the limit as x approaches -2 from the right of x times the square root of x squared plus 7x plus 10. Okay, so all we do here is we can just plug in -2 from the right in here and see if we run into any issues with the domain. If not, we can just evaluate it. Okay, so let's go ahead and evaluate it. We're going to have, by substitution, -2 from the right times the square root of -2 from the right squared plus 7 times -2 from the right plus 10. Okay, all right, let's go ahead and simplify this. This piece out here, we can write this as, just write it as -2 times the square root of -2 squared is 4, and then multiply this minus 14 plus 10. All right, if you simplify this entire expression, you have -2 times 4 minus 14 plus 10 is 0, and your final answer is -2 times 0, which is 0. All right, so there you have it. All right, let's move on to question number 4. So for question 4, I want to find the limit as x approaches infinity of 3x sine 2x. Okay, All right, so if we make a direct substitution, what we're going to have is 3 times infinity sine 2 times infinity, right? 3 times infinity we know is infinity, but what is sine of 2 times infinity, which is the same thing as sine of infinity? At infinity, sine goes between -1 and 1. It attains any value. It oscillates between -1 and 1. It doesn't approach any particular value. So this is going to be oscillating between negative infinity and infinity. So since we have an oscillation there, so since the limit oscillates, since the limit oscillates, it doesn't have a particular number that it approaches, okay? Oscillates, the limit does not exist, okay? The limit does not exist. All right, let's take a look at the next problem, problem 5. Now let's find the limit as x approaches negative infinity of x squared times x plus 5 times 2x minus 3, and this whole expression divided by the square root of x to the fourth times x to the fourth plus 2. Okay? All right, so now since we're going to negative infinity, we can look at the weights here. Okay, what's the weight of the numerator and the weight of the denominator? If you expand it completely, what we're looking at is we're going to be looking at x squared multiplied by x multiplied by 2x, and in the denominator we're going to be looking at the square root of x to the fourth multiplied by x to the fourth. So the leading term of the numerator after expanding it completely is going to be 2x to the fourth. And that's all we care about is the leading coefficient, the leading term. In the denominator, the leading term is going to be the square root of x to the 8th. All right, so we're going to take that limit as x approaches negative infinity. And then let's simplify it a little bit. We're going to have the limit as x approaches negative infinity of 2x to the 4 over, and if you simplify the denominator, the square root of x to the 8 is the same as x to the 8 over 2, which is just x to the 4th. Okay? So these x to the 4ths divide out, and then that leaves you with the limit as x approaches negative infinity of 2, and then your final answer is simply going to be 2. All right? So there you have it. All right, let's take a look at question number 6. So on question 6, we have, let's find the limit as x approaches 2 of x squared minus 4 divided by x to the third minus 8. Okay, so if we plug in 2 directly into this this expression right here, we're going to have 2 squared minus 4 over 2 to the third minus 8. We're going to have 0 over 0, which is undefined. So let's inspect this, go back to this expression, see if we can reduce it, factor and reduce it, and then substitute 2 in. Maybe that undefined value is as a result of a removable discontinuity and not an infinite discontinuity. Okay, so let's factor out the numerator. X squared minus 4 is the difference of squares, so we can use the formula a squared minus b squared equals a plus b times a minus b to factor that. And then for the denominator is the difference of cubes. So we can use the formula a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Okay? All right, so that's what we're going to use to factor the denominator. All right, so let's go ahead and apply these two formulas here. It's going to give us the limit as x approaches 2. The numerator factors into x minus 2 times x plus 2. That whole thing divided by, and if you factor out the denominator, you're going to have x minus 2 times x squared plus 2x plus 4, because in this case a is x and b is 2. Okay, just simply take the cube root of these two terms to figure out what a and b are. Okay, so there goes the factored form, and we can see that the factor causing the non-existence of the limit is a removable discontinuity. So even though we have a removable discontinuity at positive 2, that doesn't mean that the limit is non-existent there. So let's go ahead and divide or remove the discontinuity from the expression. We're going to be left with the limit as x approaches 2 of x plus 2 divided by x squared plus 2x plus 4. Okay, so now we can just go ahead and plug in 2 into the expression. We'll have 2 plus 2 divided by 2 squared plus 2 times 2 plus 4. So we're going to have 2 plus 2 is 4. 4 over, this is 4 plus 4 plus 4. 4 times 3 is 12. Divide top and bottom by 4, you're going to end up with 1/3. Okay, so there goes your results. Now let's take a look at question number 7. What if we want to find the limit as x approaches 2 from the right of 6 minus 3x divided by the absolute value of x minus 2. Okay, so we can rewrite this as the limit as x approaches 2 from the right. Reverse this order. We can write this as negative 3x plus 6 divided by plus or minus x minus 2. Okay, now we can rewrite this as the limit as x approaches 2 from the right. In the numerator, we can factor out negative 3. So we're left with x minus 2. And the denominator, since we're approaching 2 from the right, we're going to take the positive piece of this plus or minus sign. So it becomes positive x minus 2. Okay? Had it been we're coming from the left, this would be negative. Okay? So since we're coming from the right, this is positive. We take the positive piece. So these two quantities divide out. So we now have the limit as x approaches 2 from the right of negative 3. But negative 3 is independent of the direction that this limit approaches, so your final answer is negative 3. All right? So there you have it. All right, let's take a look at problem number 8. So for problem 8, what if we were to find the limit as x approaches 0 of the square root of 3 minus x minus the square root of 3 divided by x. Okay, so this one, if we plug in 0 directly, we'll have 0 in the denominator, which results in an undefined result. So this is an example where we have to rationalize the numerator. Okay, so to rationalize the numerator, we'll multiply the numerator and the denominator by the conjugate of the numerator. Okay, you get the conjugate of the numerator by switching the sign in the center. Okay, in the numerator and also in the denominator. All right, now let's multiply this out. So this is going to give us the limit as x approaches 0. If you, this is a difference of squares, so consider this being a minus b times a plus b. Okay, a minus b times a plus b equals a squared minus b squared. Okay, so if you multiply that out, this is simply going to become the square root of 3 minus x squared minus the square root of 3 squared. That goes for the numerator. Okay, and then for the denominator, we're going to simply have x times the square root of 3 minus x plus the square root of 3. Okay, let's not distribute because we might have some cancellation happening at the top. That'll take out this x, all right? So this gives us the limit as x approaches 0. In the numerator, the square and the square roots cancel out, so we have 3 minus x minus 3 divided by x times the square root of 3 minus x plus the square root of 3. Okay? You notice that these two 3's add up to 0, and then we have that negative x there, which we can divide the top and the bottom. So let me write it down again. So we have the limit as x approaches 0 of negative x divided by x times the square root of 3 minus x plus root 3. So we can now divide out this x. Okay, and then now we can plug in 0 without any problems. Okay, so if we plug in 0, this is going to become negative 1 over the square root of 3 minus 0 plus root 3. Okay, so that becomes negative 1 over 2 root 3, because 1 root 3 plus 1 root 3 is simply 2 root 3. Okay, so now let's rationalize the denominator. You multiply top and bottom by root 3, root 3. So your final answer is going to become negative root 3 over 2 times 3 is 6. So there goes your final result. All right, let's take a look at problem number 9. So for problem number 9, for the given function, determine if the limit as x approaches 4 of f of x exists, and that's for the A part, and B, determine if the function is continuous at x equals 4. Okay? All right, so the function under consideration is a piecewise defined function given by x squared minus 5. If x is less than 4, the square root of x plus 9. If x is greater than 4, and pi if x equals 4. Okay, so this is a piecewise defined function under consideration. All right, so we're going to approach the function from the left and the right to see if it approaches the same value. If it does, then the limit exists. So let's give ourselves a number line to have a solid idea of what the picture looks like. So this is the value. 4 to the left is less than. We're dealing with this function x squared minus 5. That's when x is approaching 4 from the left. And then from the right, we're dealing with this function, the square root of x plus 9, is when x is approaching 4 from the right. And then when we're evaluating f of 4, we're simply going to be looking at the constant function, which is pi. Okay? All right, so let's go ahead and consider each case. So for the limit, the A part, the limit exists if the left and right hand limits are the same. Okay, so let's find the left hand limit first. Limit as x approaches 4 from the left. We're going to be using the function that's active on that interval, which is x squared minus 5. So plug in 4 from the left, square minus 5. That's the same thing as 16 minus 5. Directionality is not really relevant here. So 60 minus 5 is 11. Okay? Now, from the right, we're going to compute the limit as x approaches 4 from the right of the square root of x plus 9 equals the square root of 4 from the right plus 9. Okay, square root of 4 is 2 plus 9 equals 11. So the left and the right hand limits are the same. That means the limit exists. Okay, so since the limit as x approaches 4 from the left is equal of the function is equal to the limit as x approaches 4 from the right of the function, and they're both equal to 11. That implies that the limit as x approaches 4 of the function exists, and it's equal to 11. Okay? So this B part is continuity. Is the function continuous at 4? F of 4 is equal to pi. Okay, based on this piecewise defined function we have up here, f of 4 is pi, so that actually is not equal to the limit. Okay, it's not equal to the limit as x approaches 4 from both sides. So since they're different, that means that the function is discontinuous. At x equals 4. Okay, in this case we have a jump discontinuity since these other two yeah, it's just, I'm sorry, it's not a jump, it's a removable discontinuity or point discontinuity since the limit exists for the function at that point. Okay, so the function is discontinuous there. All right, number 10, let's find the limit as x approaches 0 of sine 3x over 4x. Okay, so remember the formula the formula for this, if you have the limit as x approaches 0 of sine ax over bx, your limit is simply going to be a over b. Okay, using the squeeze theorem. So let me show you why that's the case here. So to show you those steps, I'm going to multiply top and bottom by 3 because I want to make it look like I want to make the argument of the sine function and the denominator identical. Okay, so multiply top and bottom by 3. You want to make it look like the limit as x approaches 0 of sine x over x, something like that. So what I'm going to do is I'm going to toss this 3 to the front of the limit, move this 4 out, and then insert this 3 in the place of the 4. Okay? So what will happen is this is going to become the limit as x approaches 0. The 3 goes in front of sine 3x over, oh yeah, 3 to 4 goes out 2, and then the 3 goes in place of it, 3x over 3x, okay? Using the squeeze theorem, we know clearly that this entire limit is going to go to 1, so this becomes 3 over 4 times 1, and then your final answer is 3/4. Okay, so there you have it. All right, let's try another example. Number 11. Let's find the limit as x approaches plus or minus infinity of sine 3x over 4x. Okay, so for this one, remember that the limit as x approaches plus or minus infinity of sine x over x is equal to 0. Okay, so this, we expect this to go to 0 by the squeeze theorem. Okay, so to show you why that's the case, I can multiply this by the same 3 and 3 so that the argument of the sign and the denominator will be the same. So we're going to have 3 times the limit as x approaches plus or minus infinity of sine 3x over 3x. Now this 4 we can put over here. Okay, so this entire limit is going to converge to 0 because this oscillates between plus or minus 1, whereas this gets infinitely large. It becomes an infinitely large negative number or an infinitely large positive number. Okay, so this becomes 3 over 4 times 0, and your final answer is 0. Okay, so there you have it. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here. You can post a comment to let me know what you think about this clip. You can like or share via your social networking program. More clips can find at www.calculus. Thanks again for watching and have a wonderful day.